Hello everyone. On this video we will be looking at your secant line. Okay. Now secant in this term does not mean the same as it does in trigonometry. So don't think that the secant is the same as, the reciprocal of cosine. It's not that. This is they just happen to share the same name. Okay, so let's look at the calculus definition of a secant line. Okay, so the secant line is basically the estimated slope between 2 points on a nonlinear graph. So on a nonlinear graph. Alright, so now let's look at this as far as on a graph. Okay, so hopefully it'll make a little more sense. But let me kind of straighten up that line a little. Good enough. Okay, so let's say we have our XY axis, where it's your X and this is your Y axis. Alright, so what we're going to do is we're going to get two X values. So we'll have this as just our X value, and further down we'll have X plus H. Okay, so let's say that X is equal to 3 and X plus H is equal to 5. X would be 3 and this would be 3 plus 2. Okay, so it's X and X plus H, so you're always going to the right. Okay, so let's say for our x-axis that our graph looks something like this. Okay, no specific graph, it works with almost any of them. Okay, so we have a point on the x-axis, and we have our point here for our X plus H. Okay, right above that point on the graph. Okay, so normally this would be your ordered pair XY. But instead, this is going to be your X, and that point is your f of X. Okay, so here, since this is your X plus H, this would be your f of X plus H. Okay, so we actually have those 2 points on the graph. Okay, so what a secant line is basically the slope between those 2 points. Okay, so basically that's just a straight line that shows the slope between those 2 points. Okay, so if you kind of think back a little bit, you remember to find the slope of a linear equation, the slope is equal to y2 minus y1 over x2 minus x1. Okay, now, since this isn't a linear equation, well, for this line, if it were linear, this would be your x2, y2, x1, y1. But since you're looking for the secant line of a nonlinear graph, your slope of the secant is equal to f of x plus h minus f of x all over x plus h minus x. Okay, so remember, this is your y1, your y2, your x1, your x2, and we're just changing those out. So instead of y2, that's f of x plus h. Instead of y1, that's f of x. Instead of x2 and x1, we have f of x plus h minus x. Okay, so if you see here, you have x plus h minus x, which really just gives you f of x plus h minus f of x all over h. Alright? And you can use either one of these, it doesn't matter at all. And these are your slope of the secant line. Or this is how you can find your average rate of change. Okay. So again, this is just a simplified version of the slope of the secant line up here, but either one of them will work. All right, so let's kind of adjust this just a little bit, and I'll show you how this works. So let's say if you have your x and your x plus h, let's say this is your graph here. Okay, so what you have is your secant line when you find the average between it. But let's say that x plus h gets closer. Okay, so let's say if we have our x, and instead of being that far, it's a little closer. That's your x plus h. Let me kind of draw my... So you have your x and your x plus h. Okay, so we're looking at the slope that's a little bit closer. Okay, so what if we get that x plus h and we move it even closer? Okay, so we have our x, and let's say this is our x plus h of our graph. So our slope is even closer. And that line goes through those 2 points. So we just keep moving it closer and closer and closer and closer and closer and closer. Okay, almost infinitely closer to each other. Okay, so in other words, your distance here is your h. Between x and x plus h, your distance is h. So that means h is getting smaller and smaller and smaller. So as they move closer and closer together, that value will be called our instantaneous rate of change. Okay, so this is our average rate of change, but our instantaneous rate of change is when it gets closer and closer to x and x plus h being almost on top of each other. Okay, so instantaneous let me move this up a little bit. Rate of change can be predicted as x plus h moves almost infinitely closer to x. Okay, and that is called our tangent line approximation, and we will cover that a little bit later. Alright, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our first example. Alright, so let's say, for example, we want to find the slope of the secant line between x equals, x equals -2. Move that over a little bit. X equals -2 and x equals 6 on the graph of the function f of x equals -x squared plus 2x minus 5. Alright, so if you have been paying attention, you know I am a big fan of number lines. They just make things so much easier. Okay, so of course we are going to start off with our number line. Okay, so we have x equals 2, this is our x-axis, x equals -2, and x equals 6. So you have -2 and you have 6. Okay, now the reason I like this is because our -2, that's our x. And our 6, that's our x plus h. Okay, so what does this tell us? This tells us that our h is equal to the distance between x and x plus h, or our two x values. Okay, so what do we do now? We find our f of x and f of x plus h. Okay, so f of x plus h, since that's your x plus h, that means that's just your f of 6. Okay, and what's your f of 6? Just replace every x with 6. So that's -6 squared plus 2 times 6 minus 5. Okay, which equals -36 plus 12 minus 5, which is equal to -29. So that means your f of 6 is equal to -29. Okay, so we're going to need that. So we're going to go ahead and put a little square. All right, now we find our f of x. Okay, so here we know that our x is -2. So that's just f of -2, which is equal to -2 squared plus 2 times -2 minus 5, which is -4 minus 4 minus 5, which is equal to -13. So we know that our f of -2 is equal to -13. And again, that's going to come in handy, so we're going to go ahead and mark that. Okay, so we know what our x plus h, f of x plus h, and f of x. That's all we need. So now, to find our slope of the secant line, we use the formula that we had earlier. So we have f of x plus h minus f of x all over. You can have x plus h minus x if you want to, or remember that's the same as f of x plus h minus f of x. The x's cancel out, so it's just h. Okay, so really your x plus h minus x is just 6 minus -2. So 6 minus -2 is just +8. So you can just make x equal h equals +8, or you can calculate it out. Either one works. Okay, so just as a little side note here. Okay, so x plus h minus x is equal to 6 minus negative 2, which is just 8. Okay, so that's your h. Okay, just a little side note so you know how I got it. Alright, so f of x plus h, that's our negative 29, minus f of x, which is negative 13, all over your h, which we already figured out is 8. Okay, so that's going to equal negative 16 over 8, which is negative 2. And that's your slope of the secant line from, move that up a little more, x equals negative 2 to x equals 6. Okay, so of course if you change your x and x plus h values, your secant line will change with it. Okay, so this is just the slope of the secant line between those 2 points. Alright, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our next example. Okay, so what if we wanted to find the average rate of change for the function f of x equals negative 2x squared plus 4x plus 4 from x equals 0 to x equals 2. Okay. Now the good thing is that the average rate of change and the slope of the secant line is just really different ways to say find the exact same thing. Okay, so there's literally nothing new being learned here. Because you're doing the same thing, they just worded it differently. So do not get confused at all if you see average rate of change and slope of the secant line. It's the same thing. Okay, so once again, we're going to start with our handy dandy number line. That's our x-axis. So it's from x equals 0 to x equals 2. So you have 0 and you have your 2, so that's your x, and that's your x plus h. Okay, now if you want, you can go ahead and just figure out what your h is, just the distance from your x plus h minus your x. Okay, so h equals x plus h minus x, which is just 2 minus 0, which is 2. So we know that your h is equal to 2. So sometimes you can just go ahead and figure that out right from the beginning. Okay, so now we have our f of x plus h. We're going to go ahead and figure that out. Our x plus h is 2, so this is just f of 2. Okay, which is just negative 2 times 2 squared plus 4 times 2 plus 4. So all we did was replace all of our x's with 2. Okay, so you have negative 8 plus 8 plus 4. Negative, let me move that a little bit. There you go. Negative 8 plus 8 plus 4. Of course, those two cancel out, so you have just 4. So we know that f of 2 is equal to 4. And again, we're going to need it, so we'll put a little square around that. Now we find our f of x. And we know that x is 0, so that's just f of 0 So that's negative 2 times 0 squared plus 4 times 0 plus 4. Here you have 0 plus 4, which is just 4. So f of 0 is actually equal to 4. Okay, let's go ahead and check that off. So we have everything we need to find the average rate of change. Okay, so to find the average rate of change, once again, we use the formula for the slope of the secant line. So we have f of x plus h minus f of x all over h, which is f of x plus h, that's our f of 2, minus f of 0 all over, well, you can put 2 or you can put h, doesn't matter because your h is just equal to 2, all over 2. Okay, so what's your f of 2? Your f of 2 is 4. Your f of 0 is 4, all over 2, so that's just 0 over 2, or just 0. Okay, so your average rate of change is just 0. Alright, so once you find your values, it's just a matter of plugging it in. Alright, so I'm going to, if you're still working on this one, feel free to press pause, but we're going to kind of alter the problem a little bit for our next example. Okay, the process is still the same, but we're going to mix it up just a little. Okay, so what if we want to find the average rate of change of the function f of x equals 3x squared plus 3x minus 1 from x equals 2 to x equals t. That's the little change. You just add x to another variable. All right. So, like I said, it's just a little bit of a curveball. You tweak your approach a little, but overall, it's the exact same method. Okay, so once again, we get our handy number line. We have from x equals 2 to x equals t, 2 to x equals t. Of course, this is our x, and this is our x plus h. Okay, so far, nothing's changed. All right, so how do we calculate our h? This is where it comes in handy to go through the steps and understand the actual concept. So if you notice, t is equal to x plus h, and x is equal to 2. So x is equal to 2, and t is equal to x plus h. Alright, so what does that give us? So if x is equal to 2, what does that mean? That means that t is equal to 2 plus h. So we solve for h, we subtract 2 on both sides. So h is equal to t minus 2. Alright, so that helps. Now we have our h. So we do the exact same thing we did on the previous examples. We find our f of x plus h. Oh, move that over, there we go. So f of x plus h. Our x plus h is t, so that's just f of t. So now we just replace every x with t. So that's 3t squared plus 3t minus 1. Okay, so we're going to use that a little later, so we keep that. Now we find our f of x. our x is equal to 2, so that's just our f of 2. So that's 3 times 2 squared plus 3 times 2 minus 1. Alright, so we go ahead and calculate that. 3 times 4 is 12. So we have 12 plus 6 minus 1, which is 17. Okay, so we know that f of 2 is equal to 17. And go ahead and mark that one since we're going to need it. Okay, so we have our h, our f of x plus h, and our f of x. So now, we go ahead and use our slope of the secant line formula to find our average rate of change. So slope of the secant line, remember that's f of x plus h minus f of x over h. We know our f of x plus h, that's f of t, minus our f of 2, all over our h, which is t minus 2. Alright, so we go ahead and replace our f of t, which is 3t squared plus 3t minus 1. 3t squared plus 3t minus 1 minus our f of 2, which is 17, all over t minus 2. Alright, so if we go ahead and simplify this, you have negative 1 minus 17 will give us minus 18. So 3t squared plus 3t minus 18 all over t minus 2. Alright, so now this numerator can actually be factored using the a times c method. So we factor our numerator is 3t plus 9 times t minus 2. Oops. Alright, so that's going to be 3t plus 9 times t minus 2 all over t minus 2, where of course these two are going to cancel out. So it's going to be 3t plus 9. Okay, so really if you go from x equals 2 to x equal any value, instead of working this over and over and over again, as you change your t value, you can say, okay, we know we're always going to start at 2, but as it changes, as t changes, I don't want to have to go through all of this again. So you just basically created a formula where if you say, okay, from x equals 2 to x equals 4, just replace t with 4. Okay, what about x equals 2 to x equals 7? Replace your t with 7. So you don't have to go through all of this again once you create a specific formula for your average rate of change. Alright. So if you are still writing, feel free to press pause. But we're going to go ahead and move on to our last example. There we go. Okay, so let's say for this example, we want to estimate the instantaneous rate of change for the function f of x equals 2x squared minus 3x minus 4 at x equals -2 using the average rate of change rate of change over smaller intervals. Alright, so just as a quick refresher, go back to the very first page of your notes. And if you notice, I'm just going to cover this up for a second. Remember, we have your instantaneous rate of change, and that's predicted as x plus h moves almost infinitely closer to x. Okay? So to find our instantaneous rate of change, we're actually going to look at -2, and we're going to get closer and closer and closer and closer to -2. Okay, using our average rate of change over smaller intervals. All right. So what we're going to do is we're going to try 4 smaller intervals. Okay. Okay, so we can see here that f of x is continuous. Okay, so since it's continuous, the rate of change will be the same from both sides. Okay, so f of x is continuous. So the rate of change will be the same from both sides approaching x equals -2. Okay, so it doesn't matter if we go from the right or the left. Okay, so what we're going to do here, just to keep things nice and neat, is we're going to create our nice little table. Alright. So we're going to look at our interval for our first column. Okay, we're going to look at our rate of change formula, which is f of x plus h minus f of x all over h. And that's going to help us find the instantaneous rate of change. Alright, so what intervals are we going to use? Well, we're approaching -2. Okay, so we're just going to get closer and closer and closer. So we'll go from -2 to -1. Okay, we're just going to do this a couple of times. Then we're going to go from -2 to -1.5. We're going to go -2 to -1.9. And last but not least, we can go from -2 to -1.99. Okay, so what we're doing is, for our, just draw a quick little number line. You know how I love those. They have -2, and this is -1. We're going from x to x plus h. So we're going from -1 to -1.5 to -1.9 to -1.99. So our x plus h is getting closer and closer and closer and closer to our x. Okay. So in this case, this is our x, and this is our x plus h. Okay, so we're going to go ahead and plug it into our formula. So f of x plus h is just f of negative 1 minus f of negative 2 all over your h, well, x plus h. Well, actually, this might be a little easier if we do the x plus h minus x. Okay, so we just went ahead and changed that there. Instead of h, just x plus h minus x, only because we have our x plus h minus x right here, and we don't have to work it out separately, so we can just work it out right here. So x plus h is negative 1 minus negative 2. So if we plug in negative 1 into our function up here, we'll actually end up with 1. So our f of negative 1 is equal to 1. So I'm just not going to work it all out because we're kind of limited on space. Minus f of negative 2, if you plug negative 2 into our function, you'll end up with 10. All over negative 1 minus negative 2 is just positive 1. So that's equal to negative 9. Okay, and just for clarity's purpose, just to make sure no one's confused, we know f of negative 1 is equal to 1, and f of negative 2 is equal to 10. And you can always plug them in to double check if you want to. Okay, so now we know for that distance, for your x and x plus h, they have a slope of negative 9. Okay, so now we do the same thing for negative 2 and negative 1.5. So now in this case, this is your x, and this is your x plus h. Okay, so hopefully you're starting to see the pattern of what we're doing here. Okay, so your slope, f of x plus h, is f of negative 1.5 minus f of x, which is f of negative 2, all over x plus h minus x. So that's negative 1.5 minus negative 2. Okay, so just like up here, I'm just going to put the little note in the corner here. If you plug in negative 1.5 into your f of x, f of negative 1.5 is actually equal to 5, and f of negative 2 is equal to 10, which we already knew that from up here. Okay, so that ends up being 5 minus 10 all over 0.5. Okay, which ends up being negative 10. Okay, so as our x plus h changes, so does our secant line. Okay, so you can't just put in one value. You have to kind of put in a couple to see where the pattern goes. Okay, so now let's try it again, but this time, this is your x, and this is your x plus h. Okay, so what I want you to do now is go ahead and press pause and try to do just this one on your own. Okay, using this same format there. Alright, so I'm assuming you've pressed pause and you've worked that one out. So we're going to go ahead and verify your answer. Okay, so your f of x plus h, that's f of negative 1.9 minus f of negative 2 all over negative 1.9 minus negative 2. Okay, so if you go ahead and plug negative 1.9 into your function, you'll end up with about 8.92 minus 10 for your f of negative 2 all over 0.1, and that would actually average out to be about negative 10.8. Alright, and just for the sake of it, we're going to go ahead and put out that our f of negative 1.9 is 8.92. And of course our f of negative 2 is equal to 10 because we already figured that out a couple times ahead. Alright. So we're going to go ahead and figure out our last interval, where this is our x and this is our x plus h. Okay, so we have f of negative 1.99 minus f of negative 2 all over negative 1.99 minus negative 2. Okay, so you can see here that our, let me give myself a little more room there, f of negative 1.99 is 9.89, and of course our f of negative 2 is once again 10. So you have 9.89 minus 10 all over 0.01. Okay, so you end up with about negative 10.98. Okay, so you can see here that as you get closer and closer, and if you put in negative 1.9999 and did the same thing, you just keep getting closer and closer and closer to negative 11. Okay, so as these two, your x and x plus h, get closer together, your instantaneous rate of change, you can actually estimate it to be negative 11, just by the pattern that you see here. Okay, so the instantaneous rate of change can be estimated to reach negative 11. Okay, and if you want to be absolutely positive, once again, you can put in negative 1.999 and negative 1.9999, negative 1.9999. You can put in as many 0.999s as you want. Okay, you'll just see that this would just get closer and closer and closer to negative 11. Okay, so once you see that, okay, no matter what, it's just going to get closer and closer to negative 11, you can just run with it. Okay, and that is how you would find your instantaneous rate of change. All right, so hopefully this all made sense, and I will see you on the next video.